You hear about the magic of AI all the time, right? But where does that magic actually come from? Well, it's not some far-off fantasy land. It's forged in silicon, inside these incredible chips that honestly feel like something out of a legend. And today, that's exactly what we're going to do. Dive into the legend of the AI chip. Okay, so to really get how AI works, you got to stop thinking about computer parts as just separate things. Instead, try to picture this: a single, giant, interconnected organism. Kind of like this magical kingdom you see here, right? You've got rivers of data flowing between all these different castles and forges, everything working in perfect harmony. So the big question is, who are the heroes running this place? All right, so in the first part of our story, we're going to meet the three core heroes. These are the main characters, the ones whose unique powers and, their changing jobs over time are what make all of this AI stuff possible today. So first up, our first hero, the CPU, the central processing unit. But look, you need to forget everything you thought you knew about the CPU being just a simple worker bee. In the age of AI, the CPU got a major promotion. Think of it now as the wise wizard, maybe the king in the castle. It's the grand orchestrator that directs the entire AI operation. And this really shows you how much its job has changed. Back in the day, the CPU was the all-purpose worker. It did everything. But now, its role is way more strategic. Yeah, it still runs the operating system, but when it comes to AI, its most important job is actually prepping the data, getting it all organized and cleaned up before passing it off to our next hero for the real heavy lifting. And that, of course, brings us to our second hero, the mighty GPU, the graphics processing unit. Now, these things were originally made to create beautiful video game graphics, right? But its incredible power has been completely repurposed. Today, it's the heavy lifter. It is the massive, powerful engine that actually drives AI. So the GPU's job now is basically to be an AI accelerator. See, instead of doing things one by one, it has literally tens of thousands of cores that all work at the same time, in parallel. And it turns out that is perfect for the huge, complex math problems that are, the absolute foundation of modern AI. But every good story needs a little drama, right? A twist. And here it is. Even the mightiest hero has a weakness. A powerful GPU, this incredible engine, it's completely useless if it's starved for data. It can just sit there, totally idle. All that power just wasted because it's waiting for the fuel it needs to do its job. And this is a huge problem in our AI kingdom. And this problem, this bottleneck, it has a name. It's called the memory wall. And honestly, it's kind of the villain of our story. It's what happens when that big river of data we talked about suddenly turns into a tiny trickle. The GPU is ready to go, but it just can't get data from memory fast enough. And when that happens, the entire kingdom grinds to a halt. But don't worry, because our third hero is about to arrive and save the day. Meet HBM, which stands for High Bandwidth Memory. Just think of it like a revolutionary, super-fast fuel pipeline. So instead of that slow, trickling river, HBM is more like a whole series of stacked-up magical springs, just gushing data right to the GPU. It completely smashes through that memory wall. Okay, so let's recap. We have our three heroes, the CPU doing the orchestrating, the super powerful GPU, and the lightning-fast HBM. But just having powerful heroes isn't enough, is it? They need to work together. They need to be forged into like an unstoppable team. So how do you do that? Well, this alliance is forged using a process that sounds just as magical as it is. It's called advanced packaging. And specifically, we're talking about a technology called CoWoS. This is basically the mystical forge that physically glues the GPU and its HBM memory right next to each other. I mean, so close that they can talk to each other at just unbelievable speeds. Now, CoWoS sounds super complicated, I know, but the name actually tells you the whole story. It just means chip on wafer on substrate. So here's how it works. Step 1. You take the chips, the GPU and the HBM, and you put them side by side. Step 2, you put them on a special silicon wafer called an interposer. Think of that as a high-speed superhighway connecting them. And then step 3, that whole thing gets put on a substrate, which is the foundation that connects it to the rest of the computer. But look, creating this amazing alliance of heroes, that's really just the beginning of the story. The quest for even more AI power is pushing us to come up with some truly radical new ideas. I'm talking about innovations that are totally rewriting the basic rules of how computers have worked for decades. So let's talk about the next chapter. It's called PIM, or Processing in Memory. For decades, computers have all followed the same basic rule. You move data from where it's stored over to the processor to do work on it. The problem is, that's a long trip, and it wastes a ton of energy. Well, PIM completely flips that idea on its head. The thinking is just so simple and brilliant. Why move the gems? Process them right here. Instead of hauling mountains of data all the way across the kingdom, PIM brings the computer power directly to where the data already lives. It's almost like putting a tiny little processor inside every single memory cell. It just completely blurs the line between computing and storage. All right, Chapter 2 tackles another really old problem. In the old way of doing things, every part of the computer, the CPU, the GPU, they each had their own little private pool of memory. They were all stuck in their own silos. And as you can imagine, that was super inefficient. The solution to that is something called CXL, or Compute Express Link. And its job is to create one single giant memory pool that everyone can share. So, CXL literally breaks down the walls between those memory silos. It creates one big shared pool of memory that the CPU, the GPU, any other part of the system can dip into whenever it needs to. This gets rid of so much wasted resource and, you guessed it, gives you a massive boost in overall performance. So, finally, let's look ahead. Let's talk about a prophecy of what's coming next. Because when you combine all these powerful heroes and these brand new ideas, what you get is this incredible self-reinforcing cycle of progress. It's literally writing the next chapter in the legend of the AI chip as we speak. And that future is all about a virtuous cycle. It goes like this. Advances in AI demand even more powerful and specialized chips. And then those new, more powerful chips make it possible to build even more advanced AI. See? The two are now locked together, pushing each other forward. And a huge part of this cycle is the rise of totally custom chips. We're moving away from those general-purpose CPUs and GPUs that are kind of good at a lot of things, and we're moving towards custom NPUs, neural processing units. These are chips that are designed from the ground up to do one specific AI job, and do it insanely well. Think understanding language, or recognizing what's in a picture. They do that one thing with just mind-blowing speed and efficiency. And last but not least, the magical forge itself is getting an upgrade. That CoWoS technology we talked about, where the chips sit side by side, that's what we call 2.5D packaging. Well, the next big thing is true 3D packaging. That's where you stack the chips vertically, one right on top of the other. This creates the absolute shortest, fastest possible path for data to travel. This is the future. And all of this brings us to one final, kind of mind-blowing thought. We are entering an era where AI doesn't just run on these chips, it's starting to help design the next generation of chips. So as these AI chips become powerful enough to design their own successors, what role are we going to ask them to play? What are we going to build with that kind of self-accelerating magic?